Hi, and thank you for joining us once again. This is Paragon Pathfinders, and here we take stress out of learning science. Today, we're going to look into Cramer's rule. What is Cramer's rule? This is simply a method for solving a system of linear equations. We have two equations on the board, the first one and the second one, and it says that we're going to solve this system of equations by calculating determinants, where the solution for each variable. What is a variable? This here is a variable, x is a variable, and y is a variable. So we're actually looking for the value of x and y in these two equations. So it's saying that the solution for each variable is found by replacing the corresponding column in the coefficient matrix with the constant terms and dividing the resulting determinant by the determinant of the coefficient matrix. So what this simply means is that like it looks quite complicated, but trust me, it's very simple and easy to understand. So what this simply means is that we are going to form matrices from these two equations, right? So to find the value of x, we're going to use this very formula. The value of x is given by the determinant of x, which I'll call the x, all over the main determinant. I might call this that's d, right? And the value for y will be gotten by the determinant of y all over that's d. Okay, so this is the formula for getting the value of x and y, and I'm going to show you how to represent these coefficients as matrices. How do we do that? We're simply going to pick the numbers in front of the letters. We have a 5 here, -3 here, 2 here, and 4 here. We shall drop those numbers and use them to form matrices. Solution. So pick the numbers. Here we have a 5, -3, 2, 4. Okay. So this is equal to 6, -7. We only picked the numbers in front of the letters. Here we have a 5. We wrote it down here. -3 can be found there. 2 and 4 can be found at the bottom. And we represented the constant term on the right. All right, let's go ahead and solve this very problem. So we're going to bring this down. I'm going to call this D, or matrix D, right? So matrix D is equal to 5, 2, -3, and 4. Remember that what we're looking for is the determinant of D. This is the main matrix. So if you can find the determinant of this main matrix, we shall use it to get the values for x and y. So let's go ahead and do this. To find the determinant of this very matrix, we simply multiply the major diagonal. This part here is the major diagonal, and here is the minor diagonal, right? Major, minor. So we multiply them together and subtract the minor from the major. This now becomes 4 times 5 gives us a 20, minus 2 multiplied by -3 gives us a -6, right? So this is equal to 20. Negative multiplied by negative gives us a positive 6. Hence, our determinant of D, which I will call that D, is equal to 26. We have gotten the value for the determinant, or the main determinant. Having found the determinant of the main matrix, we're now going to find the determinant of x and y. Remember, I told you initially that to find the value of x, you're going to find the determinant of x and divide it by the main determinant. That was what I told you or told us initially. So now we're going to look for the determinant of x. And how do we find out? We're simply going to replace the column for x with the constant terms. This is a column for x and here is a column for y. So we are going to replace the column for x with these constant terms and then find the determinant for x. Hence, this is going to be our dx is equal to, I'm going to draw a line here. So replacing the column for x with a constant term, we're going to have 6, negative 7, and we have negative 3 and 4 remaining. It now becomes negative 3, 4. Okay, we shall go ahead and find the determinant for x. We are also going to apply the same concept where we subtract the minor diagonal from the major. Hence, it's going to be 4 times 6 gives us a 24 minus, remember that 6 and 4 makes up the major diagonal, while negative 3 and negative 7 makes up the minor diagonal. Negative 7 multiplied by negative 3, it gives us a positive 21. This is equal to 24 minus 21 gives us a 3. Hence, our determinant of x is equal to 3. We're done with this. Let's go ahead and find the determinant for our y. Alright, our dy is equal to, we're also going to do exactly the same thing that we did for x, but the only difference is that we have to replace the column for y with a constant term. Hence, this is going to be, everything remains the same apart from the y. We have 5, 2, and for here, we replace negative 3 and 4 with 6 and negative 7. Hence, we have 6 and negative 7. Let's go ahead and find the determinant for our y. This is equal to, let's multiply the major diagonal. Negative 7 multiplied by 5 gives us a negative 35 minus 2 multiplied by 6, which is the minor diagonal, gives us a 12. Always remember that you have to subtract the minor from the major. Let's simplify this. Negative 35, negative 12 gives us a negative 47. Hence, our determinant for y is equal to negative 47. Alright, now let's go ahead and find the value for x and y using the information that we have gotten so far. Remember, I told us that x, to find the value of x, we simply need the determinant for x and we have to divide it by the determinant of the main matrix, which we called our D. And for y, we simply have to get our determinant for y and divide it by the main determinant D. Okay, let's go ahead and plug in our values to solve for the values of x and y. X is equal to, the determinant for x is 3 all over, the main determinant is 26, and for y, this is equal to, the determinant for y is negative 47 all over the main determinant, which is 26. Hence, we are done. X is equal to 3 over 26 and y is equal to negative 47 over 26. Now, how am I sure that this is the value for x and this is the value for y? To prove this, we can go ahead and plug these values into the original equation to check if we'll get a 6 and negative 7. This is a very simple way to check whether you're right or wrong. If After checking and it does not correspond with the right hand side, it means that you're wrong. But if it corresponds, then your answer or solution is actually correct. Now let's go ahead and do this to verify our solution. So I'm going to use equation 1 first to verify. So for equation 1, we have 5x minus 3y is equal to 6. So I'm going to plug in the values for x and y on the left hand part to check if I'll get a 6 afterwards. 5 multiplied by, the value for x is what? We have 3 over 26 as our value for x. And we have minus 3. Our y is what? Negative 47 over 26. So let's simplify this to check if we will get a 6. 5 multiplied by 3 gives us a 15 over 26. Negative 3, negative 47 gives us plus 144, plus 141 rather, plus 141 all over 26. Alright, since they have a common denominator, we can just add them up. This is equal to 15 plus 141 all over 26. 15 plus 141 is equal to 156 all over 26. And 156 divided by 26 is equal to 6. Hence, for the left part, we're getting a 6. We can say that 6 is equal to 6. Hence, our solution is actually correct. So you can try for the second equation on your own to check if you will get a negative 7. This is a simple way to solve a system of linear equations using Cramer's rule. Thank you for watching this video, and I hope to see you in the next video where we shall be solving a system of linear equations of 3 variables x, y, and z using Cramer's rule. Thank you for watching, and bye.